plus m and c are such that the equation x squared plus mx plus c squared equals 1 has a repeated root x, and also the equation x minus 3 squared plus mx plus c minus 1 squared equals 1 has a repeated root x, which is not necessarily the same value of x as the root of the first equation. How many possibilities are there for the line y equals mx plus c? My name's Jamie and I've studied maths at Oxford University, and now I coach students to help them getting into Oxford and Cambridge to study maths. So if that's something that you'd be interested in and you want some support with from someone who has over an 80% success rate, get in touch. And we're trying to work out the possibilities for the line y equals mx plus c. If we do just replace the mx plus c's with y. So this first equation will become x squared plus y squared is 1, and that's just a circle with center the origin and radius 1. So it looks something like that. How about the second guy? Well, this is x minus 3 squared plus y minus 1 squared equals 1. So it's going to have center 3, 1 and radius 1. So this is the equation x squared plus y squared equals 1, which is related to this first equation. And this one is x minus 3 squared plus y minus 1 squared is 1. Now the idea is this. The line y equals mx plus c is going to be a tangent to this circle. And sometimes an A-level question might say something like, how many solutions does this have? Or how many points of intersection are there between the circle and the line? And the way you do that is you rearrange this equation to make either x or y the subject. You sub it into this guy. This guy becomes a quadratic. And depending on how many solutions that quadratic has, that's going to tell you the number of intersections between a circle and the line. And now we've been told that if we were to do this, we would get a repeated root. And thus, if we think geometrically, this line must be a tangent to this circle. So y equals mx plus c is a tangent to this circle. Using the exact same logic, it must also be a tangent to this circle. And the question is, how many possibilities are there for this line? So the question is, how many lines can we draw that are tangents to both these circles? Well, we could draw this line that's roughly there. This line that's parallel, roughly there. It's not drawn perfectly. Try it again. So something like that. Those are two lines. But we could also draw a line maybe somewhere here-ish, not drawn perfectly. And similarly, one roughly maybe here, like so. And you can visually confirm for yourself that those are the only ways you can do